Everyone, welcome to our April Database Security Office Hours on the Ask Tom platform. It's a mouthful. I've said it forever and I still mess it up. My name is Richard Evans. Thanks for joining me. I'm a product manager of Oracle Database Security, and I'm joined by my friend and colleague, Peter Wahl. Peter Wahl is the product manager of Transparent Data Encryption, TDE, and Oracle Key Vault, OKV. And today he's going to talk to us about what's new and exciting in Oracle Key Vault 21.8. Okay. Before we get started, there's a little housekeeping here. This call is being recorded and will be available on the Ask Tom platform, maybe a week or so after the event. We won't record the Q&A, but we will record the session and make that available. If you've not joined us before, this is your session. Thank you for joining us. We do this on the second Wednesday of every month at 10 a.m. US Central. Sometimes I mess up the time zones and we have to redo it, but that's only twice a year, hopefully. We do have announcements, we have a technical topic, and then we'll have Q&A. We'll probably hold the Q&A to the end. If it's something I can answer or Pedro can answer, then we'll try to take it as we go. Otherwise, we'll give Peter a few minutes at the end to answer questions. We've got like 5 years worth of archives out there of these videos. There's probably something for you out there if you're interested in Kerberos or Database Vault or DBSAT or any of these database security features, products, options, then please take a look at our recordings that are out there on the Ask Tom platform. Off to some announcements here. I put these links, documents, notes, things we talk about on our GitHub repository. And I'll share this again in the Zoom chat. So if you're joining a minute or two late, that that GitHub link there or that QR code takes you to about 2 years worth of these kind of cheat sheets that I've put out there. So hopefully you can get the Moss notes, the links, the URLs, anything that we talk about today, I try to post out there for you. So as always, we talk about patching every month, and I've got a patching poll that I'm going to launch here, and I'd love for you guys to give us some feedback here. Patches will be released on or around April 16th. Patches are released every quarter, so we're kind of curious how you guys are doing with your patching. If you've taken on any of the monthly release, monthly recommended patches, the MRPs that are available to customers now. If you're using Oracle RAC, Real Application Cluster, please check out Fleet Patching and Provisioning as a way to hopefully streamline your patching with gold images of grid infrastructure and the database. And as always, kind of the source of truth is Mike Dietrich and his blog on upgrades and patching, MikeDietrichDE.com. Okay. So I'll let this patch poll run for another minute or so here, and I'll keep talking about the next slide. But we'd love to have your feedback and kind of understand where you're at in your patching process. And then you're welcome to put comments in the chat there too, if you want to add comments as well. We talked about this last month, but I think it's worth mentioning again. Microsoft Entra ID or Azure AD tokens are supported on all platforms, including on-prem with the 19.22 on-premises release. Okay, this does not apply to 21C. That was an innovation release, but 19.22 and then Oracle Database 23 will support these V2 tokens from Azure Active Directory, or I think as it's known now, Microsoft Entra ID. If this is something you're looking into, Alan Williams and the team have been working on the documentation, so you can check out the Database Security Guide. Chapter 8 talks about how to use these tokens and how to integrate tokens with your Oracle database environment. If you have questions or you want to hear from Alan directly, feel free to reach out to me and I can put you in touch with Alan and he can talk about this super cool project that he's working on with tokens in Azure Active Directory. I'll leave the poll up for another minute here. We've got about 50% response. Let's see if we can get that a little higher here. New updates for Database Security Assessment Tool. We've got new STIG and CISS updates in March. So some improved clarity there, working with the STIG and updating when they update or when CIS updates. We try to incorporate that there. New checks for SQL Firewall, pre-authorized URLs for autonomous database and new audit findings here. So DataSafe is getting updated every month. We've also updated the sensitive data discovery as well. So we can do incremental data discovery. We can easily add sensitive data models manually. So you can add only those columns that you're interested in. Constantly improving. That's one of the benefits of that cloud product, Oracle DataSafe, is that we can release these updates on a monthly, weekly basis here. So please, if you haven't checked out Oracle DataSafe in a while, or if you're using it, we've got some new capabilities there for you. DBSat also has some minor releases here too. So some updates in the coming, probably in the next week or so. Isn't that right, Pedro? DBSat 3.1.1 will be released.
Yeah, end of next week, hopefully.
End of next week. Okay, great. So there was a XLS writer path issue that they fixed. User profile limits are handled properly. Handling of unified enabled audit policies, some columns there, and then some excluding of those sysman, sysbackup, sysdg, and syskm from some of the checks there. So yeah, good stuff. It's good to see that we have the opportunity to add capabilities to Oracle DataSafe, Oracle Database Security Assessment Tool, DBSat, and kind of keep these products moving forward. I'll go ahead and close this poll here now. We're up to about 60%. Thanks for responding to that. And I'll share the results here for you guys as well. All right, so for today's presentation, we're talking about Oracle Key Vault. I want to highlight some of the Oracle support notes related to Oracle Key Vault. Now, Peter Wahl and team do a great job at trying to keep the documentation for TDE and Key Vault updated. But if you do have to file a service request with Oracle support, they are going to ask you for some information. So these two top notes, the SRDCs, talk about how to collect standard information for Oracle Key Vault and Oracle Transparent Data Encryption. So this will kind of help your support engineer understand like what your configuration is, what settings might be there, what parameters are available, what the environment looks like, so they can help troubleshoot and get you to a resolution, hopefully a little bit faster there. The third is a primary ID for transparent data encryption. It tries to kind of centralize the related My Oracle support notes for TDE. But again, if you can, the documentation should be your starting point, whether it's Key Vault or transparent data encryption or any of the other Oracle products. And I also say this every month, like we miss things in the documentation because we've looked at them so much. So if there are typos, if there's something that's unclear in the wording or the steps, or if you feel like something's missing, please reach out. Like file a doc bug. Those eventually work back to either us or they get to the doc writer. And if the doc writer can fix it, they take care of it. If they need some input from us, then they come to us and they say, hey, Rich, how should we word this? Or this looks a little unclear to these customers. So please take advantage of that like or dislike button, provide feedback, or send me an email. We'll take a look at it and see if we can add some verbiage there or add some clarity for you. Okay. But really nothing comes short of getting your hands on a product. So we've got an Oracle Live Lab out there on Oracle Key Vault. Please go kick the tires on this. You can run this as a green button lab. So this runs on our dime. The QR code on the screen or the developer.oracle.com/live labs. You can understand kind of how to get started with Key Vault, how to manage Key Vault with an existing wallet, how to migrate that to online keys where we're talking directly to Key Vault, no longer using that wallet, and then how to manage some secrets in Oracle Key Vault as well, which Peter's going to talk about secrets today. If you are not familiar with TDE, you don't have to be to complete the lab, but we would recommend you go check out the TDE portion of the Database Security Advanced Security Lab. Understand how to encrypt table spaces, how to rotate the master key, kind of how TDE works in the Oracle database, and then move to Key Vault. Okay, so good hands-on labs available for you on Oracle's dime, including more than 25 that you can run on our green button platform. We've got more than 40 database security related live labs out there. Some of them run on your own tenancy. Most of them you can run on our lab, or over half of them, and kick the tires. Get started with TDE, get started with Database Vault, get started with Key Vault, get started with DB-SAT, get started with DataSafe, or use it to kind of experiment. Like, well, I've always wanted to try this with this. How could I do that? We developed a Oracle TDE plus advanced compression lab because we had customers who were like, well, hey, how do these things work together? So we've got a little lab out there for you to try. I saw a lab the other day on cloning pluggable databases and incorporating TDE there too. So really good stuff that you can experiment with and learn with on Oracle's platform. Okay. Also, another learning opportunity. Our friend Pedro is going to be talking about Oracle SQL Firewall as part of a 23C EMEA presentation. Probably a little early for me, Pedro. I think it's about 3 a.m. US Central. But if you're in EMEA, if you're in India, then this is a great opportunity for you to hear from Pedro and to learn more about the Oracle SQL Firewall that is an option in Oracle Database 23C. And then what we've done with Oracle DataSafe as well with it. Okay. All right.
All right. Good morning, everyone. Good afternoon. Good evening. The first thing that I would like to show to you is where TDE and Oracle Key Vault fit into the maximum security architecture. So here's your database, completely unprotected, and what you can do to solve this problem is you can get your user population under control. We have various methods to sign on to let users into the Oracle database. Oracle Database Vault keeps administrators away from sensitive application data in your database. Label security and virtual private database are end-user tools to control what your end users can see. Data redaction masks data after it left the database on its way to the application screen, so that sensitive information like credit card numbers is not completely displayed. Certain digits can be overwritten with a hash sign, for example. And there we have transparent data encryption and Oracle Key Vault. Right? That addresses the problem that somebody could bypass the access controls in your database and tries to access the table spaces, the container of all your application data, directly, bypassing the database. And then we have data masking. This is used to get sensitive information out of your database when you clone or duplicate your databases to test and dev environments. And then we have Audit Vault, which is a data warehouse for audit records. You can slice and dice like you do with every other data warehouse, but it's about your audit records of your enterprise. The security assessment, we just heard about it. And then we have DataSafe, which is our cloud offering. And as far as I know, that can even connect to your on-premise databases and validate that everything is in good shape from a security perspective. And then we have Database Firewall, which protects you from SQL injection attacks. So TDE, as I said, it protects you from malicious users who bypass the database and try to access your table spaces directly. If those table spaces are encrypted, you cannot just copy the table spaces onto a memory stick and walk home. I mean, you can do that, but it's encrypted, so it doesn't really help. Tablespace encryption does not require application changes. It has a very low performance overhead. TDE is 20 years old now, and our developers had ample time to find the sweet spot in the database code where we most effectively can encrypt and decrypt the tablespace data when it's read into database memory. There are online and offline migration options to get from clear text tablespaces to encrypted tablespaces. If we use the online method, of course, there is no downtime, but we need more storage because we create another tablespace that is encrypted. We move the blocks over. For offline migration, you need downtime if you don't have data guard, but we don't need extra storage. So here you can choose which method you like better. Offline encryption is not a data guard transaction. Online encryption is a data guard transaction. So if you online encrypt your primary, your standby will follow. Offline encryption is usually done on the standby first. The default key management solution that comes with TDE is implemented using an Oracle wallet. That is an encrypted file that lives outside of your database. And then, of course, you can use Key Vault if you have more than 5 databases that are encrypted. You should basically look at the key management solution, and the one that comes out of the database security group is Oracle Key Vault. So I mentioned that Key Vault comes out of the database security group, and that is why we play really well with all the other features that come from the Oracle database. So on engineered systems, yes, everything works. You can encrypt, you can provide key management with Key Vault. Key Vault provides key management for encrypted ACFS file systems. This is something that only Key Vault can do. Of course, in DataGuard, we simplify day-to-day DBA operations by centralizing the wallets and making encryption more transparent, right? If you have DataGuard with wallets, a rekey operation on the primary will stop the MRP on your standby. You have to copy the wallet over and restart the MRP. If you do that with Key Vault, primary and standby have access to the new key, and they will continue to operate as if they were not encrypted. Key Vault also provides key management for encrypted GoldenGate trail files. We get to this later. And then, of course, all applications. So we don't really need a list of certified applications because TDE encrypts on the block level, where we only see ones and zeros, and we do not know where those ones and zeros belong to. Right? They could belong to a PeopleSoft index or to a materialized view in eBusiness Suite. We don't know. We just encrypt the blocks, and we don't know where those blocks belong to. And the beauty of TDE is that if you move your data out of your database, it remains encrypted, right? If you use storage level encryption products, then they will, if you extract the data, it will be in clear text. So if you build a standby database from that encrypted database here, the standby database will be encrypted. Your backups remain encrypted, export files remain encrypted, and if you store your backups in an offsite, and sometimes those backup tapes fall off the truck, they are encrypted and useless for somebody who finds them and doesn't have access to the master key. Here is a quick history lesson about the most recent TDE innovations. So, of course, Oracle Database 11 and 12 were released before cloud was a word in technology. So, and then the cloud came along when Oracle Database 12.2 came out, roughly, and we backported some of the features to the older database releases. So even in Oracle 11 GR2 and 12.1, you can offline encrypt your existing table spaces, and you can also turn on a switch that automatically encrypts table spaces even if the encryption syntax is missing from the create table space statement. That comes handy when you install an application that doesn't know anything about TDE, and that application creates table spaces, then those will be encrypted by the database at installation time. Now, in Oracle Database 12.2, we introduced the possibility to online encrypt and rekey your table spaces. And finally, we now have a method to hide the key store password from the DBAs. That, of course, adds that enable separation of duties between a database administrator and a key admin in your company. Oracle Database 18 introduces valid root. That is a database parameter, and that allows us to be independent from operating system variables and settings in SQLnet.Aura. We can also bring our own key or hold your own key for wallet-based TDE deployments. And for use cases where you have an unencrypted primary database or an unencrypted database on-premise and you would like to create an encrypted database in OCI, you could use rman restore or duplicate as encrypted. So if you don't have a TDE license for your on-premise database, your cloud database would be encrypted. Same thing, if you would like, no, I don't like OCI, I would like my database back on-premise, you can use rman restore duplicate as decrypted, and the database will be written to your on-premise database without TDE if you don't have a TDE license. So that makes your life easier and the migration to OCI easier. So a little bit more recent database releases in Oracle Database 19c. We finally can encrypt system sys, aux, temp, and undo. Starting with 1914, we made isolated PDBs available for everyone, everywhere. This down means everyone means with an Enterprise Edition license. Everywhere means, unfortunately, not in OCI. The OCI cloud tooling doesn't support isolated PDBs. So if you have an XRCS database, XRCC, autonomous Clouded customer, those are on-premise databases but still controlled by OCI. In this case, there are no isolated PDBs for you. If your databases are not managed by OCI, then you can certainly implement isolated PDBs, and Oracle Key Vault is the only key manager who supports isolated PDBs. Starting from 1916, we introduced split TDE. That is similar to the case where we have the rman restore as encrypted or restore as decrypted settings. This here is for a more permanent solution where you have an on-premise database without a TDE license, and you would like to set up a standby database in OCI that needs to be encrypted because it runs in OCI. Now, in this case, we give you a switch for your on-premise database that is called tablespace encryption. You set this to decrypt only, and then your clear text primary would send information up to the encrypted standby database in OCI, and the data would be encrypted as it's written to the tablespaces. If you do a role switch, the encrypted primary database in OCI would send encrypted data to the unencrypted standby database on-premise. And because of the switch, tablespace encryption is set to decrypt only. We decrypt before we write into your on-premise tablespaces, and that is why you don't need a TDE license. Starting from Oracle Database 1919, you can rekey cloned or relocated PDBs upon arrival. So let's say you would like to clone a PDB from an older database release, let's say 12.2 to 19c, and you would like to upgrade the PDB once it arrived in the 19c container. And the source PDB is encrypted with AES 128, but you would like to use AES 256. You can rekey this PDB on the fly, and by the time it has been completed, the relocation or the cloning process has completed and the PDB is in your target container, it will be encrypted with AES 256. In Oracle Database 21c, we introduced database vault command rules to control who and under what conditions administer key management commands can be executed. The database configuration assistant creates encrypted databases, and we have a new location for the PKCS 11 library. and a new system parameter. When the system parameter is set, we can dynamically load the PKCS11 library. And so database releases before 21C need a database restart. When we upgrade the OKV client and we give you a new PKCS11 library, that library is only loaded when the database starts. In 21C and of course in 23C, there is a parameter that allows you to dynamically load the PKCS11 library after it has been upgraded. In 23C, what will be coming is that DVCA can encrypt existing databases, and it creates new databases that are automatically, from the start, registered with OKV. We introduced a new cipher mode, XTS, which is applied by default. And we also make AES-256 the default algorithm for everything that needs to be encrypted in the Oracle database, including column and tablespace encryption, because AES-256 has the highest resistance against post-quantum crypto attacks. So here's our TDE key architecture. We have a table key for TDE column encryption and a tablespace key. Those are the data encryption keys. They do the heavy lifting of encrypting your tablespaces and your tables, or your columns in your tables. And the master key encrypts the data encryption keys. The master key, of course, lives outside of the database by default in an Oracle wallet, or optionally in Oracle Key Vault or OCI Vault if your database is run, if you like to have your key management as a service. So the data encryption keys are completely managed by the Oracle database. A key administrator or a database administrator can control the TDE master key, which lives, as I said, outside of your database. When we built Oracle Key Vault, we had a problem. So in the early days of TDE, our customers encrypted one, maybe two databases. And so the request for a key management system wasn't there yet, because if you have only two databases, well, yes, that's okay. You can handle two wallets and two passwords, and that's maybe not so dangerous. And then our customers starting to get security mandates down from their management that says, hey, every database that you create needs to be encrypted. Oh, ow. So now suddenly we have not one or two databases, we have 12,000 databases that are encrypted. If you have 12,000 databases that rely on wallets, I can promise you that you get 1 to 2 calls every day where a wallet password was forgotten, somebody deleted the wallet, or something happened that makes the wallet or the master key unavailable to the encrypted database. And that means the end of the database, because there are no backdoors in TDE. So even if you call our support people about a lost wallet, there's nothing we can do. If you forgot the wallet password, we can't help you. So we needed to come up with a solution that scales to a lot of databases, right? 12,000 databases, 18,000 databases. Our largest customers, that's what they have. We have the GBU which is the global business units. They have a service that creates databases in OCI for our GBU customers. And they have 22,000 pluggable databases managed in 3 OKV clusters deployed in 3 regions across the planet. And they cannot have a downtime. I mean, if they have downtime, my phone rings. And they don't care about what time it is. So we need a key management system that never goes down, even if you need to take it offline to apply an upgrade patch. That key management system needs to be available. We need to promise that we never lose a key, right? Zero data loss. There is no way that OKV can lose a key. we need to scale to thousands of databases, and we cannot slow down the database, right? You pay lots of money for the Oracle database. You expect the database to be as fast as possible. And when you encrypt, you also do not accept a performance degradation. Equally, if we centralize key management, we cannot introduce slowness into your setup. That just doesn't fly. Here is a quick comparison because you have two choices when you are looking for a key management solution for your Oracle databases. Oracle Key Vault in the middle can be deployed on-premise in your OCI tenancy, in Azure, and in AWS. So wherever your databases are, OKV is there for you. It can be deployed on dedicated hardware or as VM guests. We try to be everywhere. So for the XIDB Cloud@Customer and Autonomous Cloud@Customer databases, OCI Vault doesn't have a reach into on-premise data centers. So here we integrated an on-premise OKV cluster. Your on-premise OKV cluster can be registered with OCI. So your tenancy knows about the presence of that key management system. And when you provision a new Cloud@Customer database, it could be XIDB or it can be autonomous. If you create a new Cloud@Customer PDB, there is a screen that talks about key management, and there you can click a button, and then this database will be automatically onboarded into your on-premise OKV cluster. Now we have customers who move slowly and piece by piece from on-premise into OCI. So they switch from XIDB Cloud@Customer to XIDB dedicated. But they already know how OKV works. They are familiar with the interface. They know that they can trust Key Vault because it's a cluster. It doesn't go down. It's never not available. So they asked us to give them the possibility to extend an OKV cluster from on-premise into OCI so that they can share encryption keys with a primary database, XR Cloud@Customer, a standby database, XIDB dedicated in OCI or in Azure, and use a common and known key management infrastructure. So for the HSM integration, if we have an HSM, we do not support HSMs for direct TDE key management because normally HSMs do not scale to the load that 5,000 or 18,000 encrypted databases put on a key management system. And so we use an HSM to protect OKV. We call that a root of trust. And hold your own key. That's the default for Key Vault. In OCI Vault, you surrender your keys and give it to your cloud provider. And in order to implement hold your own key, they need to integrate with an on-premise HSM that you also have to pay for. So yeah, OKV has a few benefits over OCI Vault. And by the way, the number of keys, the number of endpoints, the number of CPUs OKV runs on are completely, we don't care about it. You can put any number of keys in OKV. You can connect any number of databases to an OKV cluster. You only pay for the server license. The number of connected databases, the number of keys is irrelevant for the licensing question. So here we have a typical deployment of Oracle Key Vault nodes. I mentioned that Key Vault is usually deployed as a cluster. We recommend a 4-node cluster minimum that gives you continuous read-write availability. Let's say you only have node 1 and node 2. You have a 2-node cluster, right? They are connected read-write. They are updated synchronously. If your database connects to node 1, for example, and does a set key operation, the prompt comes back only after the key has been replicated to node 2. So we guarantee you that this key is available on at least 2 OKV nodes, right? And then if you take node 1 down, for example, to apply to apply an upgrade, then node 2 will become a read-only node because it cannot replicate to node 1. Right? We cannot keep our promise to replicate because there is no replication partner. So node 2 goes into read-only mode and allows your databases to continue working. You cannot rekey, you cannot bring in new encrypted databases, but your existing databases keep working. And then when node 1 comes back after it has been upgraded, it will rejoin the cluster and it will be a read-write pair. If you have a 4-node cluster and node 2 goes down because it needs to be upgraded, node 1 becomes a read-only node, but node 3 and 4 are a read-write pair and continue to serve your databases in a read-write mode. So you can do rekey operations, you can bring in new databases, you can upload new secrets into OKV. Node 1, which is in read-only mode, will be updated by node 3 and node 4. So by the time node 2 comes back, node 1 knows about everything and will update node 2 and bring it back up to date. Here is another use case that only OKV can do. So we know that GoldenGate allows the transformation of data between almost any source to almost any target. So as an extreme example, we could maybe extract data out of a Microsoft SQL server and upload it into a Kubernetes cluster. I don't know if this makes sense, but that is just an example. So for this, GoldenGate needs trail files because the data needs to be transformed out of a SQL server format into something that a Kubernetes cluster understands. So we need trail files, and the trail files, if they're not encrypted, they are a gold mine for hackers. So that is why the GoldenGate team supports encrypted trail files, and by default they use a wallet, just like the database does. And if you change your key on the extract side, all your replication sites will stumble for a moment because they don't have that new key. So you need to copy the key to all replication sites and restart the replication process. If you put this in OKV, you do a rekey on the left side, the key will be replicated to the right side and will be available to the extract side when the key is needed there. Right? Specifically, if you have a very wild GoldenGate setup with many sources and many replication targets, and this is encrypted, you would be glad to have Key Vault managing your encryption keys because it makes it transparent. Right? The administrator doesn't have to worry about redeploying encryption keys to the replication sites. The keys are already available to those processes because we centralize keys in an OKV cluster. Here is another use case for Oracle Key Vault. I assume that you have maintenance scripts that log into your database every night, every week to create an RMAN backup, to rebuild materialized views, to rebuild indexes, whatever it does. So that maintenance script needs a powerful user account in your database and, of course, a password. Theoretically, you could put username and password into the maintenance script, but who does that? We don't have passwords in clear text somewhere. So that is why Oracle came up with the idea of the Secure External Password Store. The Secure External Password Store is an auto-open wallet that allows you to move the password of that user in the maintenance script into a wallet. You reconfigure your database so that when a certain user connects to a certain connect string, the database knows, oh, I need this wallet, the password out of the wallet, and that's how the script can log into your database to create an RMAN backup. If you change that account's password, you also have to update the secure external password store there, so that the steps you have to do just doubled, right? Not only in the database, but also your secure external password stores. Somebody could, by mistake or maliciously, delete the wallet. Then your maintenance script cannot log in. You could fat finger the new password. Then again, your script cannot log in, or something else happens. So from a security perspective, we moved the clear text password out of the maintenance script into a wallet, but we didn't address the management overhead. And if you put this password into OKV, you can very easily use OKV's RESTful services to first guarantee that the password that you're using to log into your database hasn't been used before. You can use that password only once while you are logged in. Let's say while some system user is logged into a database to rebuild materialized views. While this user is logged in, he can change his own password. We upload the password into OKV. And when that script logs in the next time, we will fetch a password again out of OKV, use it only once, use it only when it hasn't been used before, log into the database, run the script, create a new password, upload to OKV. So that cycle can repeat every night. And you know that you have a password that was only used once. They can be randomly generated. They're super strong. In Oracle Database 23c, the maximum password length for database users has been blown up from 30 characters to 1024 characters, which is impressively long. So those passwords can be put into OKV, and you're much safer and centralized than with the secure external password store. If you use ZDLRA and you would like to reinstantiate your backups in as cloud service databases, then the presence of Key Vault to make sure that your encryption keys are safe is mandatory. With Key Vault 21, we introduced a new user interface that is better prepared for large deployments, right? Because I just told you that the number of keys, the number of connected databases is unlimited. So yeah, customers do that, and that is why we need to scale to really big numbers in terms of endpoints, in terms of keys and secrets, and all these things. So that user interface has been optimized for large deployments. Of course, if you have 22,000 databases in OKV, you cannot hire 50 people to click on web pages and onboard those databases into OKV. So this is all automated. It can be scripted very easily, and you can onboard your databases in, I would say, then less than a minute. That's all automated, very easy, and we keep adding to our RESTful services. So you can monitor OKV. You can, of course, provide key management to your keys and secrets. You can provide key lifecycle management to your keys and secrets, because the OKV RESTful services sticks to the KMIP standard, right? If you want to know how the RESTful services work, you could equally read the KMIP documentation. It's the same thing. You can build a cluster using RESTful services. You can remove nodes from a cluster using RESTful services. You can schedule and define remote backup destinations using RESTful services, and you can monitor the system and cluster health using RESTful services, right? We also support monitoring through SNMP, but SNMP is a very archaic method of monitoring. It's ultra stable. It is well established everywhere. Everybody knows how to use it. But SNMP doesn't know about OKV, doesn't know about clustering. So those things that SNMP doesn't address, those are covered by RESTful services. We support custom endpoints. So if you have an application that needs passwords, encryption keys, or whatever sensitive information, you could make this application KMIP aware and outsource keys and secrets from your application into OKV and make that application KMIP aware. So it retrieves passwords and encryption keys from OKV. That simplifies the development of the application because the developer doesn't have to worry about key management so much. Key management is done by OKV. You just call the key, you fetch it, use it, and throw it away, and next time you fetch it again. Yeah, it simplifies application development. It certainly reduces the time to market for your application. And if your developers are using DBMS Crypto, which is an Oracle package that allows you to encrypt columns in your application tables, a documented weakness of DBMS Crypto is the lack of key management. Now, OKV21 enters the picture, and yes, we can provide key management for DBMS Crypto. The persistent master key cache. So OKV creates, protects, and maintains a persistent cache and an in-memory cache on your database machine. Those caches are created and maintained by our PKCS11 library. That's where the intelligence sits. The memory cache has a default expiration time of 60 minutes. The persistent cache has a default expiration time of 1 day. So your databases can lose connection to the entire OKV cluster for up to 24 hours, and they will continue to work. What we are suggesting our customers to do is to shorten the persistent cache expiration time down to 4 hours, but make the persistent cache refresh window crazy long. Say 14 days, 21 days. We had a customer recently who had encrypted databases in a data center in South Africa, and the Key Vault cluster was in London. And then, as you may know, 2 or 3 weeks ago, there was a big network outage because a submarine internet cable broke or stopped working. And that exactly that hit our customers directly. So the OKVs in London were unreachable to the encrypted databases in South Africa. We knew that they have a persistent cache that runs, that allows the databases to continue to work for 24 hours. But do we know if the submarine cable is repaired after 24 hours? No, we don't. And so the customer had a team of 20 people trying to reroute traffic, bypassing the broken submarine cable. And this database was so important, it was not possible to let this database go down. So under no circumstances. So we were lucky that the customer could, within 24 hours, they could reroute the traffic and everything was good. But let's say this was not possible. By reducing the persistent cache time to 4 hours, but increasing the refresh window to 2 weeks or 3 weeks, we could have waited for almost a month for this connection to come back. So after this event, we reconfigured our Key Vault, so the next time this cable breaks, we're good to go. Yeah. Here is how an HSM protects OKV. OKV is using TDE inside. We have a password protected wallet. When we have an HSM connected to OKV, the wallet password is randomly generated. It is written to a file, and this file is encrypted with a private key, with a symmetric key that we get from the HSM. So if at the time when OKV starts, at one point it needs the wallet to be open. If we see, oh, this is password protected, and here is my password stored in an encrypted file, OKV will reach out to the HSM, send the encrypted password to the HSM, get it back in clear text, open the wallet, and then we can start. That also means that if you install OKV as a virtual machine, a rogue VM administrator cannot just take the disk image on a memory stick and walk home. with your keys? Yes, he can do that, but it will not start up because it doesn't have a connection to the HSM. Okay, cloud database integration. I talked about this earlier. We try to be everywhere where your databases are. So in Autonomous Database Cloud and Customer, OKV was integrated into the control plane in October 2020. For XRDB clouded customers, we had a manual integration available in February 22. The control plane integrations phase 1 was completed in July 23. Phase 2 will come sometime in the middle of 24. Phase 2 will allow automatic OKV client upgrades and data guard setups. So this will come in the next phase. And we have a MOS note out on how to integrate OKV with the XRDB dedicated cloud service and XRDB dedicated at Azure. And the automated integration equal to what we do for XRDB Clouded Customer will also come to XRDB dedicated, but I don't have a date yet. Here's how it looks like. On the first side is a one-time setup where you register your on-prem Key Vault cluster with OCI, and then on the right side you see that on the key management side, when you provision a new database, you can pick and change the key management system, and you can make your OKV key store available to this new database, and it will be migrated automatically. So as I said, we try to be everywhere. This is an OKV cluster with on-premise nodes and OCI nodes from the cloud marketplace. We have quite a handful of customers who have a picture like this, where they're moving from XRDB Clouded Customer onto XRDB Dedicated and need the encryption keys on-premise and in OCI, and they are, of course, replicated, sometimes synchronous, and the keys are available everywhere. Now, in this picture, you could also replace one of those two clouds with AWS and the other one with Azure. Right? As I said, we try to be everywhere. So a new use case that came with OKV 21.7 and was refined and improved in 21.8 is SSH key management. So SSH key management is important for public key authentication. Everybody's using it. This is a use case that allows OKV to enter a market that is much bigger than only the Oracle customers, because every IT shop has remote servers that developers or administrators need to access remotely. So here we have an SSH user on the left side who has access to 3 remote servers. So in order to make public key authentication work, we need to get the user's public key into the authorized keys file on the remote machine. How do we do this? So the user on the left side could know the server password and copy the key himself. That defeats the purpose. We want passwordless authentication. So there is password-based authentication could theoretically be disabled in those machines. You require public key authentication. So in this case, we need to send the public key to the administrator on the right and bother him to, hey, can you please copy my public key into the authorized keys file so that I can log into your machine? If you have hundreds of people on the left side and 500 servers on the right, you can see that the administrators on the right will most likely not do much more than copying public keys into the authorized keys file. And also from an authorization perspective, this becomes very complicated. Right? Our user on the left, the one with the blue public key, only has access to 1 remote server. The person in the middle has access to 3 servers. The lady on the third lady has only access to 2 different servers. So her public key is copied to 2 machines. And so on the right side, we see where the public keys are present. You can see if this number grows to 500 administrators or 100 administrators working on 500 remote machines, you can see that this becomes very convoluted and most likely a security issue, right? Because private keys live on the users and workstations on the left. If I steal a private key from somebody and log in to some remote machine and do something, then the evidence of what I do points to the owner of the private key, not to me. So you really need to pay attention and take care of your private key and make sure that nobody steals it, nobody can copy it or messes with it. So this is a huge mess. And also when people change roles on the left side, are we 100% sure that those changes are reflected on the public keys? On the right, maybe not. Maybe there are keys on those remote machines that haven't been used in 20 years. Right? Nobody knows. Nobody knows. Nobody can answer any questions that come with this wild deployment of public key authentication. So if we move the private keys of the users into OKV and also the public keys into OKV, this looks much cleaner because it is managed centrally. And if it's managed centrally, that also means that we can report on it. We know whose public key is used. We know whose private key is used. We know how often somebody logged into a machine. We know everything because it's centralized. So let me quickly go through an example. So this is our first use case. We have a user, John, on the left side who likes to connect to Phoenix on the right. In order to do this, we have John's public key in the authorized keys file, and John is using a very familiar command to log into the remote machine. Now, if we would like to provide access controls to the remote machine, we would install an OKV endpoint on the remote machine and also create a server wallet in OKV. A server wallet is a new type of wallet that we introduced specifically for SSH key management. The SSH server wallet can only have access to an SSH server endpoint. That's a new endpoint type that we introduced. And the SSH server wallet can only contain public keys, nothing else. So in this case, we upload the public key into the SSH server wallet. We give the remote SSH server endpoint read-only access to the SSH server wallet. And our user, John, can already connect without interruption. There was no interruption for John. He can, as he did before, connect to Phoenix with the public key centrally managed in OKV. Now, how do we do access control? Our SSH admin removes the public key from OKV, and John can no longer connect. When the key comes back, we can connect. So that's how we enforce access controls. And now here we have our reports that go with this. And now we go to the user key management, to the private key governance, right? Because we want to know more about our private keys. So what we do, the SSH administrator creates a public key pair in OKV. This is how the page looks like. And you see that the wallet membership is already addressing John's wallet. John's wallet now contains a private and a public key. John's OKV endpoint has read-only access to this wallet, and the private key is non-extractable by default. That means the private key cannot leave the cluster boundary of OKV. But now, if John likes to log in, he can use this command to download the public key and copy the public key to the remote machine and log into the remote machine like before. But this is not really what we want. So if we combine both solution with, if we apply both use cases to the solution, then we have on the left side, We have a client wallet where John finds his key pair. The private key is non-extractable. John has read-only access to the wallet. There is nothing he can do but use the keys. The administrator copies the public key to the server wallet, and John connects to the remote machine. And there are no keys, there are no SSH keys on John's workstation. There are no SSH keys on the remote machine. And here are the reports. You can certainly look at them in the OKV Live Lab, for example. So I hope that I didn't run over time.
Just a little bit, but we're good. You got some good information here on where to go to the labs and our office hours, and then that ebook, right?
Yep, exactly.
Yeah, great stuff.